All right, let's finish up this chapter. So I am on the bottom of page 512, and the author mentions back in chapter 8 we learned about try parse and how it's used, why it's used. It says, suppose that no try parse existed. And what they're mentioning is if it didn't, you could write your own. So if you look on page 513 at the top of the page, they've got one that you could write. And pretty much, in essence, this is what happens in it anyway. You know, someone had to go and write a library file that you could use, all right? And that's pretty much, you know, what they're showing here is pretty much what they did. All right, I mentioned this finally block before. The finally block is optional. What does that mean? It means you don't need it ever. And that's a lie. What I just told you was a lie. All right? Why is that a lie? If you put a try, it really makes sense to only have one or more catches. Okay? But it is legal. I don't know why you would do this, but you can have a try without any catches. So we could remove all that, but then you need a final. Again, I don't know why you would do that. I have never done that, but the point is you can. Not that you should, but that you can. All right? Again, finally is typically, since it executes regardless, it's typically used for what are usually referred to as housekeeping operations. All right? In other words, if you've got a file open, you might want to close it. If you've got a database open, you might want to close it, etc. All right? But remember that when you run a try-catch, as they mention on the top of page 516, what happens? The try works. We look up on the screen here with the stuff that I wrote on the board. You do those 4 lines, they all work. So you skip the catch and you do the finally. That's the first possibility. Second possibility, the try doesn't work. So it goes in and it does the catch, then it does the finally. All right? Third, the try ends abnormally and the catch does not execute. What the heck does that mean? Well, remember this program that we just looked at here, this one? All right? What if I had in here, if I didn't have these 2 exceptions? I'm going to show you something. So I'm going to come in here, I'm going to take this line, just comment it out for now, and I'm going to put in here catch, index, out of range, exception. All right? So I'm going to put in that. E. All right? And this whole thing here, I'm just going to take this and comment it out. So what I'm trying to get to is, I'm going to make an error in the program. Everybody hear me? So when I make that error, it's going to try to find a catch that matches it. There's not a matching catch. All right? You know, not a great example, but it's like, okay, we want to go out and have a football game today. You come there with a baseball glove on. You know, wrong stuff for the wrong sport, or right stuff, but for the wrong sport type of an idea. Well, look what happens here. So I run the program, and I'll put in 9. Still is hanging. Try it again. Now it's, whoops, well, I screwed up. So the system is saying, all right, again, if you look, it's saying we had a divide by 0 exception, right? But look, I don't have a divide by 0. So the system took over for me. Rather than it calling this code that we put in, this thing that said, this is not your fault, you know, all that garbage, what does it say? It says, basically, nothing. All right? So the point is, if you do not put in an exception that the system realizes, it calls its own exception. All right? So if you don't do it, you know, if you don't write the correct code, the system says, well, I don't know what you mean, so I'm just going to call my own code. All right? That's what they start getting to with this handling exceptions, you know, thrown from outside methods, etc. So what happens is this. Look on the screen if you would, and look on, and back to the left. You got this try. You've got an error. So what the system does is it says, is there a catch in there that matches it? Let's say it doesn't find one. Then it goes and it looks at whatever function called this function. It says, does that have a catch in there that catches it? If it doesn't, it says, what function called that one? What function called that one? It keeps going up. Eventually it gets to the top, it gets to main, and it says, there ain't nothing. Then it throws its own exception, and the program just aborts. That's exactly what they're saying here on pages 517, 518, and 519, and 520 for that matter. All right, turning up all the way to page 521 in your book. Tracing exception objects through the call stack. This is the call stack. The call stack has what routine in your program called what routine. It's got the latest one to the earliest one. So if I write a routine and I say I've got F1, and F1 calls F2, and F2 calls F3. Just leave it right there. All right? Then the call stack would have F3 on it, then it would have F2 on it, then it would have F1 on it. Does that make sense? It's got everything that was called in the reverse order from which it was called, so latest to earliest. All right? This isn't that big a thing in here working with a call stack, but a year from now when you're working in Java, it gets to be a really big thing, because what you can do is called propagate the exception. So it moves its way up the call stack. So again, with those examples I just showed you, if F3 throws an exception and it's not handled in F3, it looks in F2 to see if it handles the exception. If it doesn't, it goes to F1 to see if it handles the exception. It still doesn't find it, it aborts. That's exactly what they're talking about with tracing the execution on page 521. They give you an example that's on 522, 523, 524, which gets us all the way to page 525. Now you might think, wow, you're whipping through this pretty quick. Yeah, I am. All right. But I'm giving you the highlights. I'm giving you the most important stuff. We're going to see several examples of this tomorrow. You can also create your own exception. So if you look on page 526, here's an example. The good news is when you create your own exceptions, these are really small files. This is almost exactly the way you do it in JavaScript. Almost exactly. Or I should say in Java. It's almost exactly the way you do it in Java. This is your own exception. So you're creating your own exception called negative balance exception. And it is a child of, or it inherits from, exception. Then what you say is, I want it to basically say this. But it's not strong enough to say it here, so you got to call the parent. Now, do I expect you to understand that? No. But the point is, imagine I'm doing a miles per gallon program. Everybody with me? So you're saying, read in the miles driven, read in the gallons used. And let's say for the miles driven, it has to be between 1 mile and 1,000 miles. So that'll be for the miles driven. And for the gallons used, it has to be between 1 and, let's say, 50. So that's gallons used. So if you put in a miles driven that's zero or negative, or you put in a gallons used that's 0 or negative, those are errors. But there is no built-in exception that says miles driven exception, gallons used exception. So if you use this format that's shown up on the screen there, you can make your own exception. You will be doing that on your test. All right? So they show it, and they show how it's used on page 527, how you can throw your own exception, and I think they show you, do they show you on 528? Yeah. So this is what happens when you actually throw it. It says whatever the heck you want it to say. So we could say here, for example, miles driven must be between 1 and 1,000. And that's what would show here, instead of bank balance is negative. All right, we could say gallons used must be between 1 and 50. instead of bank balance is negative. All right. And the last thing that's discussed in the chapter here, the last thing, is called rethrowing an exception. And it's on the last couple pages of the chapter. The author says when you write a method that catches an exception, your method does not have to handle it. Rather, you might choose to rethrow the exception to the method that called your method. This is again called going up the call stack. So what we're saying here is if we want to have one place in the program that handles all of our catch statements, we can do that. Even if we've got a lot of different routines in that file that throw different error messages. All right? You'd have to take a read on that for it to make any sense to you. All right, if you would please, turn up to page 533 in your book. Let's do the review questions. Number 1, an error condition or unexpected behavior is known as, what's number 1? A, exception. Number 2, which of the following is not treated as a C# exception? The answer is B. You have no control if the person hasn't installed the compiler. That's not an exception, that's idiocy. All right? So number 1 is A, number 2 is B. Number 3, most exceptions will derive from these 3 classes. The answer is B. Exception, system exception, and application exception. So number 1 is A, number 2 is B, number 3 is B. Number 4, next page. Exception objects can be C, both of these. They can be generated automatically by C# and they can be created in your program. So number 4 is C, both of these. Number 5, when a program creates an exception object, the answer is actually B. You can handle it. Remember, it's not that you must. If you don't handle it, the system handles it for you. So number 4 is C and number 5 is B. Number 6, if you do not use object-oriented techniques, the answer is D. You can still manage error situations, but you have to use if statements. So number 6 is D. Number 7, in object-oriented terminology, you try a procedure that may not complete correctly. So 6 and 7 are both D. Number 8, in object-oriented terminology, a method that detects an error condition, A, throws an exception. That's the terminology that's used. So number 8 is A, throws an exception. Number 9, when you write a block of code in which something can go wrong and you want to throw an exception, if it does, you place the code in a D try block. All right, number 9 is D. Number 10, a catch block executes when its try block C throws an exception of an acceptable type. So that's that page. Number 4 was C, number 5 was B, number 6 was D, number 7 was D, number 8 was A, number 9 was D, and number 10 was C. Number 11, next page. Which of the following catch blocks will catch any exception object? The answer is B. B as in boy. This one. Number 12. Which of the following is valid within a catch block with that header? The answer is D, 2 of these. A is valid and B is valid. Both A and B are valid, so the answer is D, 2 of these. So number 11 is B, number 12 is D. Number 13, you can place The answer is D, any number of statements within a try block. All right. Number 14, if this is on your test, I'm throwing it out because the answer is, two answers actually work. Number 14 is B, like boy, if there is no finally. And D, if there is a finally. So it's B or D depending on the situation for number 14. Number 15, the answer is C, 99. You never hit this line of code here because you already threw an exception. So for that page, it's B for number 11, D for number 12, D for number 13, B or D for number 14, and C for number 15. Next page, number 16. The answer is B, 1. Number 16, the answer is B, 1. All right, one of these will hit. The value is 0, and one of those will hit, so it'll add 1 to it. 0 plus 1 is 1. Number 16, or 17, I'm sorry. Number 17, the answer is C, 2. Why? Because that will hit right there, and that will add it, change it from 0 to 1, and that will hit, which will change it from 1 to 2. So 16 is B, 1. 17 is C, 2. 18. If your program throws an index out of range exception and the only available catch block catches an exception, the answer is B. That block will execute. Remember, the one that just says exception is the most generic. It'll catch anything. So 16 was B as in boy, 17 C as in cat, 18 B as in boy. Last page, number 19. When you design your own classes that might cause exceptions and other classes will use them, you usually create your methods B to throw exceptions but not handle them. You let the user handle the exception any way they want. So number 19 is B, like boy. Number 20, when you create an exception subclass of your own, you should extend the D as in dog, exception class. Now, please look on the screen here. Your homework for Chapter 11 will be numbers 1 and 2 that you see on the screen right here. Page 537, numbers 1 and 2. And then I'm going to turn up 2 pages to page 539. And it's 6 and 7. So 1 and 2 and 6 and 7. We will do either 2 of them tomorrow or 3 of them tomorrow. All right? And 1 of them you will do on your own. All right? Last thing, and then I'm finished for the period. If you look up on the screen, please. Where is it? File. Come on. Open. Thank you. That's not what we want. This is your test review or your study guide for Chapter 11. So if you'd please open it up. This is what I emailed you, the empty one this morning. All right. The first one, how many C# defined exception classes are there? The answer is there's actually more than 100. All right, so number 1 is greater than 100. Number 2, compiler errors are not considered to be exceptions because you have no control. If the compiler screwed up, it's not your fault. The second part, you can deliberately generate a system exception. You also can place any number of exceptions in a try block. So notice, this is one question right here if you look on the screen. This is 3 different questions on your test. All right? Number 3, all C# exceptions are objects that are members of the exception class. The exception class is a child or descendant of the object class. All right. Number 4, if you attempt to store an element of the wrong type within an array, you get a system.arrayType mismatch exception. All exceptions end with the word exception. Ones that you write should also end with the word exception. Does everyone have those first 4? Yes? All right, then let's move on. I guess 4 was a bigger question than I thought. So there is all of 4 right there. All right. So again, that is 3 different questions. That's probably, looking at these are probably in the multiple choice category, I would guess. I don't know for sure. But notice, wrong type, mismatch, aborted, aborted, invalid, invalid. All right? Pretty much usually the key to what you're looking for is in the question itself. Number 5, robustness, the degree to which the system is resilient. So can the system remain functioning if an error happens? If it can, it's robust. Everybody have those first 5? Number 6, an infrequent C# event fires less than 30% of the time. Please look at number 7, 10% of the test. 4 out of 40 questions are on the screen. Actually, 5 out of 40. So what is a try block? When you write a block of code where something can go wrong, you put it in a try block. What is a catch block? Each catch block can catch one type of exception. What is a finally block? Usually used for housekeeping operations. It executes whether the try succeeds or the try fails. What's unreachable code? It's also known as dead code. It's code you can never get to. So if you look up on the screen here where I said if line 3 was an error in that try block, line 4 you could never get to, so line 4 would be dead code. Everybody has those first 7, correct? Well, here's the next 4. The C# exception class overrides the toString method. It contains a read-only property called message. I already showed you that. All right, that has useful information on it, in it, whatever you want to say. Number 9, try parse is used for conversion. Number 10, environment.exit can be used to abort a program run. Number 11, hit enter a couple times here. When you've got problems with a file, an I/O exception is what is thrown. All right. Sorry, I got to jump back into this for a second. I'll go right back to the program in just a minute. Does everybody have those 4? 8, 9, 10, and 11? Yes? All right, let's move down then. Let me open this up a little bit. It's too hard to read otherwise. All right. Notice again, 4 questions, 10 more % of your test. Everybody have those? Again, that's 5 different questions on the test. Everybody's all caught up? Right, Jesse, there's everything. All right, here's the terminology. So here's the first 6. Leave that up there for a minute. Does everybody have the first 3, 16, 17, and 18? And that's everything.